Let's measure the angles in this triangle using a protractor. We'll begin with this angle. Place the protractor so that the center point is directly over the vertex. Make sure that your baseline of your protractor lines up exactly with one arm of the angle, and then follow the other arm of the angle along to see where it measures on the protractor. Make sure you start at 0 and work your way around. This one looks like it's pretty exact at 35 degrees. All right, 35 there. Let's move to this angle. Again, we position our center point directly over the vertex, and we can work this way, or we can turn the protractor and work this way. Both will get the exact same answer. In fact, let's try both to prove it. I'm going to start at 0, where my baseline is, and go around until the point where the other arm intersects the protractor. I have 56 degrees. Now let's try it if we do the protractor in the other orientation. And if we do it this way, we start at 0, work our way around, and look what we get, 56 degrees. So that's proof that it does work in both directions. Now let's do this angle. And I have an idea of what this angle might measure. I have a suspicion it's going to be very close to 90 degrees. It sure looks like a right angle. But let's test it out. Place our protractor. And we follow along the baseline, work our way up the numbers, and follow where this second arm of the angle extends, and it actually goes to 89. Not exactly 90, 89 degrees. But I do notice something. The angles in my triangle are 56 degrees plus 35 degrees plus 89 degrees, which gives me a total of 180 degrees. But we already knew that the sum of the interior angles of a triangle was 180 degrees, didn't we?